Hey class, Miss Anderson here. If you're watching this, that means I am probably not in class, so I apologize for that, but I'll get you through it. So today we're doing 3.3 and we're going to prove that two lines are parallel. So that's our goal, to prove that two lines are parallel. All right, and today we're learning about the converse of the theorems that we learned back in 3.2. And remember, we learned about the conditionals. And remember, a conditional is like if P, then Q. So we first learned the conditionals, or the original theorems, back in 3.2. So let me just go back a couple pages here and look at our original theorems. So we learned like the corresponding angles theorem, and that we've been using to find the values of these different angles, all these theorems we've been using so far. So the corresponding angles theorem said that if the lines were parallel, then the angles were congruent. So if the lines were parallel, then 2 and 6 were congruent. Then we had the alternate interior angles theorem that said if these lines were parallel, then alternate interior angles were congruent. Then we had alternate exterior angles theorem that said that if these lines were parallel, then the alternate exterior angles were congruent. And the consecutive interior angles theorem said that if these lines are parallel, consecutive interior, so on the same side of the transversal inside the parallel lines, are supplementary. So if they're parallel, they add to 180. And so those were our original conditionals, if then. And today we're looking at the converse. And remember back from Unit 2, when we learned about what a converse was, that was if Q, then P. So the corresponding angles converse is the reverse of the first theorem we looked at, which says that, if the corresponding angles are congruent, then the lines are parallel. So reversed. So looking at this example picture, it would be if angle 2 is congruent to angle 6, then J is parallel to K. The alternate interior angles converse says that if you have these angles and they're congruent, then these lines must be parallel. So if angle 4 is congruent to angle 5, then J is parallel to K. So that's that. And notice that the name of these are different. It's followed by converse. So this would be alternate interior angles converse. Similarly, alternate exterior angles. So those involve the outside of the parallel lines and alternate along the transversal. If those are congruent, then the lines must be parallel. So if angle 1 is congruent to angle 8, then line J is parallel to line K. And that's AEA converse. And then consecutive interior angles. So we're looking at the angles on the inside, and then consecutive means that they're on the same side of the transversal. If they are supplementary, then the lines must be parallel. And remember that supplementary means that the angles add to 180. So we could say that if the measure of angle 3 plus the measure of angle 5 is equal to 180, then the lines are parallel. So today we're going to work on proving the lines are parallel by showing the if part. So we're going to prove the if part, then the lines will be parallel. And then we're going to say one of these converses that we're using. So our goal is to find the value of x that makes the lines parallel. And then we're going to state the theorem that we're using to solve it. So if we look at our first example, we have line M and line N, and we're going to try to show that that is parallel because those lines are parallel. because this line must be your transversal, because by definition, a transversal is a line that intersects two or more lines. Line M only intersects this line, so that can't be a transversal. So this is the transversal. So looking at the transversal, we have these two angles. Now these are corresponding angles because they are both on the same side of the transversal and the same side of the line, which would be the top right corner. So we're going to try to use the corresponding angles converse, which says that if the corresponding angles are congruent, then line M will be parallel to line N. And we know that if we want to make these two angles be congruent, they have to be equal to each other. So we're going to go ahead and set 2x plus 3 equal to 71, and then we're going to solve for x. So we're going to subtract 3, and we're going to get 2x equals 68, and you're going to divide by 2, and we're going to get x equals 34. Okay, so if x equals 34, these angles should be congruent. So I'm going to plug this back in just to make sure. 2 times 34 plus 3. That would be 68 plus 3 is 71. So if x is equal to 34, then these two angles are both 71 degrees, which would mean that the corresponding angles are congruent. So then the lines are parallel. So I'm going to have to say that x has to be 34, and then that would be the corresponding angles converse. And we have to make sure to say converse because the corresponding angles theorem says that if the lines are parallel, then they're equal. But we want to prove that the angles are equal to show that the lines are parallel. So that's what we're doing this time. All right, looking at number 2, looks like part of it got cut off. This line here that's running diagonal is your transversal. So these are the lines I'm going to try to prove if they're parallel. Let's call this one P and this line Q. Now, if I look here, I have my transversal. These two are both on the same side of the transversal. And then they are on the interior sides of the parallel lines. So these are consecutive interior angles. So I'm going to want to try to prove using the consecutive interior angles converse that if the two angles add to 180, then the lines have to be parallel. So I'm going to find a value of x so that those angles will add to 180. So if there'd be consecutive interior angles are supplementary, then P and Q would be parallel. So to prove or to find a value of x that would make them supplementary, I'm going to have to add the equations together and set them equal to 180. So in this case, you got some like terms. So 2x and x is 3x, 10 and 5 is 15. Then we're going to subtract. So then 3x is equal to, let's see, 165. We're going to divide by 3. Okay, so 3 times 50 would be 150, and I need what, 15 more? So 3 times 5 is 15, so 55. So x equals 55 should give me two angles that make 180. So let's double check and plug it back in. So if x is equal to 55 and I plug x back in here, 55 plus 5 would be 60 degrees for this one. And then if I plug it back in here, 2 times 55 would be 110. 110 plus 10 more would be 120. And then 120 and 60 are supplementary angles because they add up to 180. And so then I do have, if corresponding angles are supplementary, then the lines are parallel. So this is true if x equals 55, and I will be using the the consecutive interior angles converse. So we're going to make sure that we write converse with it so that we know that we are using the converse, not the original theorem. All right. One more we're looking at, this is the transversal. So we have alternating angles. They are on two different sides of the transversal. And then we have interior angles because they are inside the parallel lines. So this is an alternating interior angles. And we have a theorem that says that if the lines are parallel, then the alternate interior angles are congruent. And then the converse is if alternate interior angles are congruent, then the lines will be parallel. So that's what we're going to try to prove. So we're going to try to find the value of x that would make these angles congruent. So we're going to set them equal to each other to try to figure out what it has to be. Actually, I'm going to start with the 5 because it's bigger. 5x minus 54 equals 3x plus 16. All right, then I'll subtract 3x from both sides. Get 2x minus 54 equals 16. Then add 54. So 2x equals 60, 70. Divide by 2. X equals 35. Okay, so if x equals 35, these two angles have to be the same. So let's just make sure we did that right. I do have my calculator. I'm just going to save me a little bit of time here. So 3 times 35, plus 16, give me 121 degrees. And then 5 times 35 minus 54 also gives me 121 degrees. So if x is 35, then the alternate interior angles are congruent, then A is parallel to B. So that would be using the alternate interior angles converse. So two answers. I want what theorem and what value of x makes that true. Okay, so then just deciding whether or not there's enough information to prove that the angles are, or to prove that the lines are parallel means that we have to have one of these 4 cases. So you either have to have corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, or consecutive interiors are supplementary. So in this case, this is my transversal. These are alternating along the transversal, and they are interior. And this means that they are congruent. So there is enough information. We would say that alternate interior angles are congruent. Then M is parallel to N. That's the alternate interior angles converse. Okay, similar problem over here, number 7. They're alternating, one's on one side of the transversal, one's on the other. And then they're exterior because they're both on the outside of the parallel lines. And there is an alternating exterior angles theorem that's our converse that says if alternating exterior angles are congruent, then the lines are parallel. So that's the alternating exterior angles converse. Okay. This one, this is our transversal. This is an interior, and this is an exterior. The only time we have interior and exterior that are congruent is if they're corresponding. But this one is on the left, and this one's on the right of the transversal. And so they aren't corresponding, because corresponding is on the same side of the transversal, same side of the line. So like here and here. So these alternate, and then one's interior, one's exterior. There is no alternating interior, exterior. So this one is not enough information. Not enough information given. Okay, here, this is an example, and number 9 is an example of corresponding. They're both on the same side of the transversal and the same side of the line. So here and here, they're corresponding angles. And we have one that says if corresponding angles are congruent, then the lines are parallel. So that would be the corresponding angles converse. And then in this one, it just has a pair of, in number 10, it just has a pair of vertical angles. Now, vertical angles are congruent anytime two lines intersect. And so this does not give me enough information to prove that any of these lines are parallel. So not enough information. Okay, so in summary, there are the 4 converses. We got the corresponding angles, converse, the alternate interior angles, converse. Oops, I meant to write converse up here. Alternate exterior angles, converse. These are all using congruent angles to prove lines are parallel. And then you have consecutive interior angles, converse, which uses the interior angles are supplementary. And these are all used to prove the lines are parallel. A lot of times students miss the points on the test for these because they forget to write the word converse. So please practice using the theorem so that you know which converse theorem you are using, and make sure to write the word converse behind it, because there is a difference between the conditional and the converse, and we are using the converse in these ones. All right, have a great rest of your day. Thanks for watching. I can figure out how to show